Salts worksheet 4, question 7. It says sodium hydroxide reacts with an acid to give you sodium chloride. So at this point, you can make a guess that the acid used is hydrochloric acid. That is how you get your chloride. So at this point, you know that this reaction is a reaction between acid and alkali, giving you salt and water. It is a neutralization reaction. Next, they tell you that acid is placed into the burette, while sodium hydroxide is placed into the conical flask. An universal indicator is used instead of the common metal orange. So universal indicator is placed in the conical flask. When we look at the graph, it says draw two intersecting lines. That means you must draw two lines that will cross each other, two straight lines. Okay, so between 20 and 22 degrees Celsius, that is the difference of 2 degrees Celsius. There are 5 divisions, so you do need to count how many degrees Celsius is per division. So that is 0.4 degrees Celsius. So in between 20 and 20.4, in the middle of the division, will be 0.2 degrees Celsius. So we'll start by plotting the first point, which is 21 degrees Celsius. So that is just in the middle of 20 and 22. Next, the next point is 2 cubic centimeters. Temperature is 24.2 degrees Celsius. So the first division is 24.4, so 24.2 is in the middle of that. The next division, the next point will be 27.4 degrees Celsius. So you count 26.4, 26.8, 27.2, and then there will be 27.6. So 27.4 is in the middle of the two divisions. The next one is 30.7. So 30.4, 30.8, it will be slightly below the second division. The next one, 32.9 degrees Celsius to 32.4, 32.8, it will be slightly above that. Next one, 31 degrees Celsius, so temperature is coming down. 31 degrees Celsius will be between 30 and 32. The last point, 29.2 degrees Celsius. So 28.4, 28.8, 29.2, exactly on that third division over there. So once you have plotted all the correct points, then you need to draw the best straight line. The best straight line has to be found between all the points over there. So usually we use a pencil and we'll draw. So the next 3 points look more in line, so we'll draw the next 3 points in one line. So try to find the best fit. Try to adjust the best line that you can get and then draw a straight line across. So this would be how your graph looks like, two intersecting lines. The graph is 3 marks. So how do you get these 3 marks? You get 1 mark for the points correctly plotted. You get 1 mark for drawing 2 intersecting lines. That means they are straight and they cross each other at one point. And the other 1 mark is for you to draw the lines straight through all the points. That means you don't stop at the last point, but you draw it all the way extended. So you draw it extended like that, both ways, all the ways extended. That's where you get the third mark. Okay, so now we look at part B. It says use the graph to complete to determine how much acid needs to completely neutralize. So neutralization takes place at the highest temperature of the graph that intersects. So if you look at the graph, the highest point at where it intersects is somewhere at this point. So you need to use the graph. When they say use the graph, you need to draw it into the graph. So since it's the highest point, you will draw dotted lines all the way down to see the amount of acid needed. So that will be 7.6. And accordingly, that will be the highest temperature. However, they did not ask for the highest temperature. They only asked for the amount of acid necessary. So based on that, that is 7.6 because it's 0.4 cubic centimeters away from 8 as well. So because it says use the graph, you have to draw it down to the graph. So that is 7.6 for the answer for part B. For part C, they have added 12 cubic centimeters of acid. So if 7.6 cubic centimeters of acid is where it is neutral, then once you pass that 7.6 cubic centimeters of acid that you have added in, once you have added past that amount, it means that the mixture is no longer neutral, but instead is becoming acidic. So the indicator used was universal indicator. So color of universal indicator in acid can be red, orange, yellow. The acid used here is hydrochloric acid, which is a strong acid. So because universal indicator in hydrochloric acid is a strong acid, the color we will put is red instead of orange or yellow. For the next part D, part 1, it says name the acid used. So earlier on, we have come to the conclusion that the acid used is hydrochloric acid. For 4D, part 2, it says write a chemical equation. So first step, you can write the word equation so you know what is formed. So hydrochloric acid reacts with sodium hydroxide to form sodium chloride and water. This again is our acid plus alkali or acid plus base reaction that gives us salt and water. So once you know this, you write down the chemical formula for hydrochloric acid and sodium hydroxide, which is by memory HCl and NaOH. For chemical formula of sodium chloride, refer to the periodic table. You get Na plus and Cl minus. So since the charges are balanced, you get NaCl. Water is by memory, so you get H2O. Then you check if the equation is balanced. So one way to check if the equation is balanced is to write down the elements on the left hand side, the elements on the right hand side, and count. So hydrogen there's 2, chlorine there's 1 on the left, sodium there's 1 on the left, oxygen there's 1 on the left. On the right, hydrogen there's 2, chlorine there's 1, sodium there's 1, and oxygen there's 1. So all the numbers are balanced, so that is your balanced equation. So write it down, HCl plus NaOH, arrow NaCl plus H2O.